The geometric distribution stems from the binomial distribution. You will still have an event that either happens or not, or doesn't happen. You will have a P or a Q, but the random variable X is no longer going to be the number of times in which the event happens. It will be instead the number of times it takes for the first success to take place. In this case, again, this is no longer a binomial distribution. This is going to be called a geometric distribution. And the only parameter that you need to know is the value of P. I'm going here in a bit, but I think it's better for you to understand with an example. So I'm moving a little bit down. And the example I give is this. The probability of a 1 being scored after a 6-sided dice is rolled is, as you know, 1/6, as long as the dice is fair. This means that the probability of any other score is 1 minus 1/6. It's 5/6, right? For any other score that is not a 1. What is going to be X now? X is now going to be the number of times the dice is rolled until a 1 is scored. Okay? So what does this mean, for example? I just put this one randomly. Px equals 4 means what? Means that you are calculating the probability that the first time the 1 is seen is on the 4th trial. Right? So what happens before this event? When R was 1, the 1 was not scored. Okay, what was the probability associated with this? It is 5/6. On the second time you roll the dice, the 1 wasn't scored, something else was. What was the probability of this happening? 5/6. Same thing when you threw the dice the third time. 1 was not scored. Here is the probability. When is it scored? On the 4th trial. On the 4th trial, the 1 is scored. And what is the probability associated with this? Is 1/6. If you combine all of these, what do you have? You have 5/6 to the power of 3, 5/6 cubed, times 1/6. So what is the general expression for you to calculate the probability of an event happening on the rth trial? Is going to be basically Q to the power of R minus 1 times P. In this example, don't forget, R was 4. So this is Q to the power of 4 minus 1, which is 3, times P. Q in this case was 5/6. P is 1/6. So this is the expression. What does this part mean? This means that R cannot take any other values than 1, 2, 3, etc. All right? Don't forget that R is the trial in which the event will happen. Okay? So it doesn't matter to talk about, doesn't make sense to talk about R's such as 0, 1/2, whatnot. That's what this means. All right? The distribution is going to be something like this. It's much more likely that the event will happen on the first event than in the second, than in the third and fourth, etc. If you think of it a little bit, it makes pretty much, it makes sense. What does this mean? Now, this is the probability that the event will happen after a certain number of trials. Okay, so let's say that R is 5. What is the probability that X? What is the probability that X happens after the 5th event? For X to happen after the 5th event, it means what? It means that it didn't happen until the 5th event, right? So if you think of it, this makes pretty sense. The probability is the probability that it didn't happen, that is Q, to the power of the number of times that you know that didn't happen, which is 5. All right? Again, you have here Q, but don't forget that the only parameter that you need to know is P. Q can be calculated from P. It's 1 minus P, okay? What does this mean now? This is the probability that X happens on the rth trial, knowing that it didn't happen before a certain trial. For example, let's say that we want to calculate the probability that x equals 5, knowing that it happened after the third trial. If you look at the over here, you want the probability that x happened here, knowing that it happened after this. So it didn't happen before. All right? So what does this mean? If you know that this value over here is 3, okay, x happened after the third event, what is going to be this n? You know that 3 is going to be r, which is 5 minus n. So 5 minus n equals 3. So what must be n? N is 2, right? 5 minus 2 is 3. Make sense? So again, I'm asking what is the probability that x happened on the 5th trial, knowing that it happened after the 3rd. If this happens, all you need to calculate is the value of n over there. So if you know that this is 3, and if you know that r is 5, then n needs to be 2. And once you know that, you just calculate the probability that x equals n. This is going to be corresponding to this probability over here. Okay? Last but not least, the expectation can be calculated. I'm not going to explain how to get this expression, but it's calculated just doing 1 over p. So in this case, the expectation, the number of trials that you are expected to use until a 1 comes up, is 1 over that, which is 6.